Recall multiplying polynomials. If you want to look back, that is section 5.3, multiplying polynomials. So if we're going to multiply a monomial times a binomial, we distribute that monomial to each term. So that would be a times b plus a times c. And if we're going to multiply two binomials, we need to distribute each term to each term. So we multiply a times c plus a times d, and then distribute b times c plus b times d. And generally you'll have some like terms to combine. For squaring a binomial, you'll have to be careful to multiply that binomial times itself. And so you're going to be distributing a times a, that's a squared, and a times b is ab. Then distributing b times a, that's ab really, and b times b, that's b squared. So we will have the same middle terms that we can combine together to be two ab's. So there'll be two of the same term to combine in the middle. And if you're subtracting instead of adding, so a minus b times a minus b, it's going to be very similar. So let's go ahead and distribute. That's a squared minus ab plus b squared. The only thing that's different there is that the middle term is going to have two negative terms instead of positive, so minus 2ab in the middle. And if you're multiplying the sum and difference, this is really nice because that will cancel out the inner and outer products. So a times a is a squared, and then negative ab plus ab minus b squared. So you see the minus ab plus ab cancels out, and that just leaves a squared minus b squared. So we're going to use that to multiply some expressions here, general multiplication rules. And example A, then we're multiplying a monomial times a binomial, so we're going to distribute. There's just one thing to remember when multiplying, right? Outside radical, inside radical. You can multiply what's outside, you multiply what's inside. Okay. So square root of 2 times 6 plus square root of 2 times square root of 10. So for the first term, 6 is not in a radical, so it stays outside. For the second term, though, both of those are inside of a radical, so I can multiply them together inside the radical by the product rule. And then it looks like I can simplify because 10 is 2 times 5, so I do have a square root of 2 here. And the 5 stays inside. So these are not like radicals, they have different radicands. So this is as simple as this product gets. For b then, we're going to distribute each term to each term. So square root of 3 times square root of 2 plus square root of 3 times 7. And then distribute the minus square root 5 times square root 2 minus square root 5 times 7. So the first term then, both are under the radical. I'm going to multiply them together under the same radical. For the second term, 7 is outside of radical, 3 is inside. For the third term, they're both inside, so I'm going to multiply them together inside. And the last term, 7 is outside, 5 is inside. Okay. So let's simplify what we have here. There's not enough factors to have a perfect square, so that stays. Multiply together to be 6. Same here, 5 times 2 doesn't simplify, so I'll keep it together. And let's see if we have any like terms. They all have the same index, but none of them have the same radicand. So that's it. I don't really need to put them in any particular order. This is the simplified product. For C, we're going to multiply, and actually this looks like a special product of the sum and difference. So if I wanted, I could say, yeah, this is the same first term, same second term, different signs between them, right? So that'll be the first term squared minus the second term squared. So the first term is square root of 5y, and the second term is 2. And when you square a square root, that cancels and leaves 5y. Does this represent positive real number only? Well, it doesn't say that. So we're going to assume positive real numbers only for the variables. That way I don't have to put the absolute value around that variable. We'll assume it's positive. And 2 squared is 4. So that's the really fun thing about multiplying the sum and difference. It will cancel out the radical, making this a rational number. Assuming y is not irrational. But that's our simplified product. Those are not like terms, so they stay separate. For D, we have a squaring here, so we're going to multiply this base times itself. Okay. And I can use that special product if I want, but I'm just going to distribute. So multiply root 3 times root 3. And root 3 times negative 7. Then multiply negative 7 times root 3. And negative 7 times negative 7. So for the first term, those are both under the radical. I'm going to multiply them under the same radical. For the second term, the minus 7 is outside of the radical. Another minus 7 outside of the radical for the third. And the last term, that's going to be positive 49. So there is a square root of 9, that's 3. These are like terms. I can add them together. The number negative 7 plus negative 7 is negative 14 root 3's altogether. Okay. And then we have like terms here. 3 plus 49 is 52. Everything else stays the same. Those are not like, so that is our simplified product.